Hey guys, welcome to the last video in the Chapter 7 series. So in this last video, we're going to get our first introduction to a couple of chemical reactions that you'll be responsible for knowing. So by the end of this unit, there will be 4 chemical reactions where if I give you the products, if I give you the reactants, you'll be able to predict the products. And then I could ask you to do a series of things like balance or do some stoichiometry, something like that. But today we'll talk about the first 2 of the 4 chemical reactions that you're responsible for. So the first reaction that you're responsible for is something called a combustion reaction. So a combustion reaction is when a hydrocarbon compound burns in the presence of oxygen, and it will always produce the same 2 products. It will always produce carbon dioxide and water. Okay, so let's break that down a little bit more. A hydrocarbon. Well, hydrocarbon is exactly what it sounds like. A hydrocarbon is a molecule that contains just hydrogens and carbons. So this is an example of a hydrocarbon. All kinds of examples of hydrocarbons. They form some pretty intricate molecules. So we could have C2H4. We could have C4H8. We could have C4H13. We could have C8H25. So there's all kinds of different hydrocarbons that can be made. But the one thing that a hydrocarbon has in common is it's just carbons and hydrogens. So that compound will burn in the presence of oxygen, or sometimes you'll say it's combusted with oxygen. So remember, oxygen is one of our diatomics. So when I say this is a combustion reaction, you're going to need to know that it's oxygen and specifically O2. Oxygen doesn't exist as O by itself. It always exists as a diatomic. Okay. So the way that this is going to be formatted is I'm going to say something like the hydrocarbon CH4 is combusted. What is the balanced chemical equation? So I'll give you the hydrocarbon. You'll have to know that it reacts with oxygen. And then the products will always be carbon dioxide and water. Carbon dioxide and water. The difference between different combustion reactions is in the balancing. So depending on what the hydrocarbon is, you'll see different coefficients all throughout the chemical reaction. So many combustion reactions, the first step will be to balance the chemical equation. Okay, so that's a combustion reaction. We'll see one at the very end of the slideshow again. The second type of reaction that you are going to be responsible for from Chapter 7 is a very common one. So it's an alkali metal that reacts with a halogen. So remember, alkali metals are in the first period or the first group on the periodic table. So examples would be lithium, sodium, potassium. Those very often will react with a halogen. So remember, our halogens are in the 17th or 7A group, all the way on the right-hand side of the periodic table. Again, our halogens are diatomics. So fluorine, chlorine, bromine, iodine. Those are all diatomics. That's why you see this right here in the balanced chemical equation, because those halogens are diatomics as well, just something you'll need to know. Okay. This is the general format for these reactions. So this one actually has, this one kind of has a recipe for you, because the metal and the diatomic will always come together in the same format. So there's a little bit of a recipe for this one. If you forget the recipe, it's pretty easy to figure this out if you keep the ionic rules in mind. All right, so let's look at our first example. So how might I ask a question like this on a quiz, exam, etc., etc.? So here's a good example. So I might say something like sodium reacts with chlorine, write the balanced chemical equation. So the first thing you're going to need to do is recognize that this is in fact an alkali halogen. So recognize that sodium's in group 1, chlorine's in group 7. It's going to be in this classification of chemical reactions. So that's the first step. The next step is to get all of the formulas onto the paper. So before we can balance, we need to at least write what the chemical reaction looks like. So sodium reacts with chlorine. That's our reactant side. So sodium is Na, and it reacts with chlorine. And again, you're going to need to recognize chlorine as a diatomic. So just like oxygen, chlorine does not exist as just Cl by itself. It will always exist as Cl2. So that's something that you're going to need to know. Okay. So when sodium and chlorine react, here's kind of our formula, our recipe. We know that they'll form a compound together. So when sodium and chlorine come together, they'll come together as NaCl. Okay, so how do I know it's NaCl? Well, remember when sodium forms an ion, it'll form a +1 ion. When chlorine forms an ion, it'll form a -1 ion. Flippity flop the charges, and we just get NaCl. Okay, so first step is to get the formulas onto the paper. Second step is to go back and balance. So here we could split it in half, take inventory. I have 1 sodium on this side. I have 2 chlorines on this side. 1 sodium, 1 chlorine. So I want to go back and I want to balance the chlorine. So that means 2 of these molecules are formed in each chemical reaction. That changes chlorine, also changes sodium. So now our chlorines are balanced. Check. Sodiums are not. So this tells me I must start with 2 atoms of sodium. Okay. So that's the process. And I might say write a balanced chemical equation. I might say what's the coefficient on sodium chloride or on the product. I could say something like that. So just a number of ways that I could ask about these questions. Let me get rid of this. And what you'll see when I click is that balanced chemical equation. Okay. So let's look at one more example of how I might ask these questions. And what this does is it is going to pull together a lot of skills that we've worked on in this chapter. So it's going to pull together balancing, it's going to pull together stoichiometry, and it's going to now pull in these combustion reactions. So the question is this: how many moles of CO2 are produced when 3 moles of C5H12 is combusted? So go ahead and pause the video and see if you can go through this. Okay. So first thing I'm going to do is just kind of quickly write down a list of what I need to do to get through this. So the first step is going to be to write the combustion reaction. And RXN is just my shorthand for reaction. Step 2 is going to be to balance the equation. And then step 3 is going to be stoich my way through it. So I just put stoich. Okay. So I need to get the combustion reaction on the paper. I need to make sure the equation is a balanced chemical equation. And then we're going to use stoichiometry to get to our answer. So first things first, let's get the combustion reaction on the paper. So combustion reaction, hydrocarbon. So we're always going to be given the hydrocarbon. That's something that'll just be in the problem. So hydrocarbon reacts with. So in a combustion reaction, what does hydrocarbon always react with? Oxygen. Oxygen is a diatomic. To produce. The products for combustion reactions are always the same two products. So one of the products is going to be carbon dioxide. The other product is going to be water. Okay. So there is our combustion reaction. That's the first step. The next step is to balance the equation. So let me just change colors here so you can see my process through balancing. So carbon, we're going to have 5 of them. Hydrogen, there's 12. Oxygen, there's 2. I'm going to write the elements in the same way. And then carbon is 1. Hydrogen is 2. And then oxygen, always be careful here. It's in 2 different places. So we've got 2 oxygens from carbon dioxide. We've got 1 oxygen from water for a total of 3. Okay. All right. So we've got some work to do. Nothing's balanced. The place that I always kind of like to start is with the carbons. That's just where my eye always gets drawn to. So we've got 5 carbons on the reactant side, 1 carbon on the product side. So I'm going to predict that, well, I bet 5 of these molecules are going to be made. I bet that's how it's going to go. Okay. So if I put a coefficient, let me change colors again here so you guys can see this. So if I put a coefficient of 5 in front of carbon dioxide, that's going to give us 5 carbons. So that balances our carbons. Yay. But what is that also going to affect? Yep, it's going to affect our oxygens. So coefficient times subscript, so 5 times 2, that's going to change this one to 10. We haven't done anything with this 1 yet. So 10 plus 1 is going to change that to 11. Okay. So our carbons are balanced. Let's just keep working our way down. So let's do hydrogens next. So we've got 12 on the reactant side. I've got 2 on the product side. So my prediction is that 6 water molecules are likely going to be formed. So if I put a 6 right there, we're going to take coefficient times subscript. So 6 times 2 is going to give me 12 hydrogens. So that balances our hydrogens. Yay. But what does it also affect? It also affects this oxygen here. So we've got 10 oxygens from carbon dioxide, and we now have 6 oxygens from our water. So that's going to, again, change our grand total. So 10 plus 6, we've got 16 oxygens. Okay. So carbon's balanced, yay. Hydrogen's balanced, yay. Oxygens are not. So if we end our chemical reaction with 16 oxygens, we must have started our chemical reaction with 16 oxygens. So in order to start with 16 oxygens, that means we're going to have 8 of these molecules. Coefficient times subscript gives me 16. So that's balanced. Okay. So step 1, write the combustion reaction. Step 2, balance the equation. Okay. Now we have a balanced chemical equation. Now we can dive into the math. So I'm just going to flip to the next slide and write down our balanced chemical equation on that slide. Okay. So we've got C5H12 plus 8 oxygens will produce, I don't remember, 5 carbon dioxides and 6 waters. Okay, so there's our balanced chemical equation. Now let's take a look at what it's asking us. So it wants to know how many moles of carbon dioxide are produced when 3 moles of our hydrocarbon is combusted. For some reason, these kind of problems mess with your minds. If we think about the stoichiometry maps that we did before, remember we had grams of A, moles of A, moles of B, grams of B. Okay. And so when I give you something in grams and I ask you to solve for grams, you're like, sweet, I'm just going to do some stoichiometry. Well, in this question, we don't have to address the grams at all. So in this question, we're starting with 3 moles and it wants to know how many moles. So essentially, I've taken out this step for you and I just want to know this guy down here at the bottom. I really put these problems in there to help you guys, okay? I'm trying to take 2 steps out of the problem, but for some reason when I do that, you're not in rhythm anymore, and it throws you off. So I just wanted to really be explicit about how we're going to go about solving this. So we're doing stoichiometry. We're just doing this bottom step down here at the bottom, the mole-to-mole ratio. Okay? All right. So unit conversion, we're converting from moles of hydrocarbon to moles of carbon dioxide. So what's the very first thing we do for every unit conversion problem we've ever done? We write down the measurement that was taken. So 3 moles of our hydrocarbon, draw our train tracks. Moles of our hydrocarbon are going to go on the bottom or go diagonal because that's what we're canceling out. And what's our destination? Our destination is moles of carbon dioxide. Okay. So when we're doing the mole-to-mole ratio, where do we get the numbers that go into this train track? We get them from the balanced chemical equation. So carbon dioxide is on the top. What coefficient is attached to carbon dioxide? We see that 5 is attached to carbon dioxide. So I'm just going to pick it up and set it down right here. And then looking at our hydrocarbon, what coefficient is attached to our hydrocarbon? Remember, it's an implied 1. So I'm just going to put a 1 right here. Multiply across the top, divide by the bottom. So 3 times 5 divided by 1 is going to give us 15 moles of carbon dioxide. So that's the answer I'm looking for. Okay. This is a great question. This would be a question that would probably be worth lots and lots of points. So I try to break it down in the exam, try to kind of help you through that. But it would be a problem that would be worth, it could be worth 9 points. I could easily say each step is 3 points. So it's a heavy duty problem, but something that is certainly a fair question that I could ask of you. So that's it for chapter 7. We are done with the information from chapter 7. So get to studying. It's a big chapter. Hope you guys found this helpful.